Good morning. Okay, let's say hi to Goose here. She's looking for attention. She needs some love. She did not get enough love today. Yeah, just look. She just did not get enough love. What poor little thing. Poor little Goosey. Never gets enough love. Even though she's so sweet. She just never gets quite enough love. Oh, poor thing. Poor little Goosey. Poor little Goosey Poo. Right, Goosey? Such terrible things happen. Terrible, terrible things. Okay, let me just update the website here, and we should be good to go. Oops, wrong page. Okay. This goes there. Boop-a-doo. Make it blue. And publish. Okay, we should be good to go. We got a few people here. Good morning. Okay, I think we can pretty much get started now. So let's see here. Cancel that. Get out of here. So just before, oops, that's not what I want to do. Okay, squared paper. There we go. Yikes. Okay, now I'm ready. Okay. So I'm gonna put a document out at some point today. Oh, excuse me. Oh, thanks. I'm gonna put out a document today. I said that I would try to do it yesterday, but I didn't quite finish it. I'm almost done. The document outlines kind of what the expectations are for the final assessment of the year. So yeah, I've mentioned this a few times to some of my classes yesterday, and then also today. So I feel like I'm just repeating myself, but that's okay. You guys haven't heard it yet. Oh, hi, Goosey. Oh, she stuck her claw right in my nostril there. Okay, so this is how it's gonna work. Each of the final exam, or each of the okay. I'm just gonna sort of make a diagram here because it's gonna help me explain this. Okay, so your final assessment. Okay, Goose, go away. Okay, final assessment. She's trying to play with my little pencil here. Oh my God, Goose. I don't know if you can see this, but Goosey. Okay, that's very cute, but we're busy. Okay, so the final assessment is going to have two parts. Part A and Part B. Part A, there's no choice. Everybody is going to do the same Part A, and this Part A is a topic map. Okay, so the topic map, this is, I got this idea from Mr. McIntosh, actually. I think it's a great idea. So the idea of a topic map is to go through the different topics in our class, the different topics that we've learned. I'm going to say a minimum of 10 topics, but I hope that you would do more than 10. And the idea is that you would make a little map of these different topics, and you would connect different topics if they had any sort of connections. So if they were related to each other at all. So yeah, you could do one that was maybe trigonometry, and maybe you could do the Pythagorean theorem, and then you would say that they're connected by right angle triangles, RAT. So you do that with a minimum of 10 different topics, and it would be a nice little graphic thing. You could draw it on paper and then scan it, send it to me. So that would be your Part A. Part B this is where you would get a choice. So part B would be a choice between final exam, so that would be one choice, or a project. Okay, so the final exam would be that would be administered over a Google Classroom. Okay, it would be the same kind of exam that you could expect from like a typical 3-hour final exam. Oh, I don't know why I'm yawning so much. I got a really good night's sleep. That's probably why I'm yawning, because I slept so well. So the final exam would be the same length as a 3-hour exam. You would get 5 hours. You would have 5 hours to from the time that it's available to you to the time that you would have to finish it. So what that means is that I'm allocating 3 hours for writing the exam, and then 2 hours for scanning and uploading all of your documents. Okay, so if your Wi-Fi cuts out for half an hour or something, that shouldn't be the end of the world. You should still be able to upload your stuff, because you would have a 2-hour window to upload your documents. So that's how that would work. So that's the final exam. The other option would be a project. So the project is going to have exactly the same due date as the final exam. So if you're thinking that maybe you want to do the project because it might buy you some extra time, I don't think that's really going to work here, because they're going to be due at the same time. So the project, there's definitely a lot more flexibility with the project in terms of the content matter and the form that the project takes. So I put a fair amount of information about some of the expectations for the project and for the final exam. Oh my gosh, excuse me. On this document. So take a look at this document, read it very carefully. There's also some information about our final mark and how the final mark is calculated, and some things that may be relevant to you about the final report card. In particular, we already know that the lowest grade that you can get is whichever grade you got on March 23rd. So, and that was the same with the last report card. So, that kind of raises just, a few red flags for teachers, because, I mean, if someone got like a 95 or something on March 23rd, then that leaves very little incentive to continue working, right? So we have also recently been asked to report on the extent to which students have been participating in the remote learning that we've been providing. So there will be a new section on the report card this year that will be about participation in remote learning. So if the teacher feels as though there was a lack of participation, and that lack of participation led towards a student not covering all of the curricular outcomes of the year, then that student may be required to participate in recovery learning, which is a new initiative being led by the government of Manitoba. So if you want to learn more about this, there's lots of information online. If you look up recovery learning on Google or recovery learning Manitoba, and then look for the government of Manitoba's website. I would say make sure that you're getting your information from the government of Manitoba and not like from a news article or something, because the government web pages have lots of information and it's very clear. So make sure that you're getting your information from the source. But yeah, take a look at Recovery Learning Manitoba, and I mean it probably doesn't apply to you, but you might want to think about it. So yeah, just be aware that that's a new part of our report card. And Yeah, so so that's how our final assessment is going to work. Okay, Goose is now eating my kettle. Goose, look at this. She's kind of a wild one. Well, she's not doing it anymore, but I have my kettle right over there, and she was just eating it. What you doing, Goosey? Okay, we're gonna get started right away. We're gonna continue our investigation into trigonometry. Should be pretty fun. We're not gonna do a whole lot today, but I am going to assign a little bit of homework. So yeah, that's what we're doing today. So there you go, nice clean shot of Goose's bum. Nice bum shot. Okay, let's get started then. Are there any questions about the final assessment before we jump into it, or should I just get started here? I'm thinking we can probably just get started. I am going to post this document at some point today. Oopsies. Yeah. Okie dokie. Okay, no one's really saying anything in the chat, so I'm gonna move forward. So yesterday we were looking at how circles are related to triangles, especially with respect to trigonometry. So I'll kind of recreate that image that we've been working with, and I want to just point out a few different things about it. Let me just get this nice and evenly. There we go, and there we go. Okay, perfect. Here's my axes. Oh, I want the geometry. Okay, there we go. Nice straight lines. Beautiful. Okay, and I think that looks a little uneven. Let me just move this up a wee bit. Whoa, what the heck? Okay, that's a little bit better, I think. Okay, great. So we looked at sort of a kind of a, not an issue, but something sort of interesting, that if we have an angle here, right? If this is our angle theta, okay, and this would be a circle with radius r, then this point right here, just based on trigonometry, would have the coordinates, x, y, where x is equal to, well, this would be cos of theta, and y would be equal to r cos theta, r times cos theta, and we would have r times sine theta. So that would be the coordinates of that point. And the coordinates of that point end up being quite important. So how about we invent a new system? And this is a system that actually is well used, especially in calculus and in pre-calculus and sort of the next sort of topics that you guys are going to be looking at over the next few years. Isn't it kind of annoying, this r? Who cares about r, right? So here's what we do is we've kind of decided that we are going to base our trigonometry on this kind of circle model, except in this case our r, we don't want to have this r. R is going to be equal to 1 now. We're going to say r equals 1. So what we've done is we've made a circle with a radius of 1. We have a circle with a radius of 1. And that radius of 1 tells us that, okay, well now the xy coordinates are just actually sine and cos themselves. Okay, so that's really all sine and cos are, is that it's the coordinates of the point defined by our terminal angle. So just to give you kind of an idea of how this works, let's talk a little bit about, here we go. Okay, so I'll draw kind of a nice big one here, and I'm gonna sort of just eyeball it. Hey, that one didn't look too bad. So so if I were to ask you, like the coordinates of this guy right here, and let's say that theta was 25 degrees, okay? I want you to tell me, and then here r is equal to 1, what are the coordinates of our point xy. Okay, so I'm going to give you about 30 seconds to do this one. I'd like you to actually give it a shot. So here's 30 seconds. Okay, so if this is our situation, we've got a radius of 1, our angle is 25 degrees. What are the coordinates x, y of this point here? And I'll sort of make this point a little more visible. This pink point here, what are the coordinates of this point? So 30 seconds, go. Okie dokie. Just 1 second. Okay, so let's get started here. Okay, so really, x here. I mean, what I'm going to do is I'm going to just sort of make a little right-angled triangle here. That's sort of based off of this. So this distance right here is our x, and this distance right here is our y. So I'm gonna sort of copy this triangle here. So here's my y, here's my x. I know that r is equal to 1. That's our hypotenuse. And then this is our angle, 25 degrees. So this is 25 degrees. Okay. So let's see if we can solve this. So let's see. Okay, so you know, sine of theta is equal to opposite over hypotenuse, so that's y over r. And then cos of theta is equal to x over r, right? Adjacent over hypotenuse. So sine of theta is equal to y. Sine of 25 degrees, I should say, is equal to y, because r is equal to 1, so I just kind of erase the denominator, right? And then cos of 25 is equal to x. So let's pull out our good old handy dandy calculators and see what we get. Okay, so y is going to be sine of 25. So sine of 25, that's equal to sine of 20, that's our y. Let's do x first, actually. So cos of 25 is 0. I'll do 3 decimal places, 0.906, and x is y is sine of 25, so sine of 25 is equal to 0.423. Okay, so that would be the coordinates of those points. Okay, so isn't that neat that the coordinates of the points on this little circle with a radius of 1, that's exactly what sine and cosine are. It's just the coordinates of that point. Okay. Okay, so just want to go over a couple of things here. So remember that, and maybe what I'll do is I'll copy this just so I don't have to make it again. Copy and paste. Copy and paste. Okay, there. Okay, so so here's some food for thought. So we've seen that angles can go all the way around here. It doesn't matter really where that terminal side is, right? We know that our initial side is always this one right here, right? This is always our initial side. right? And then any kind of other angle that we make, it could be over here, it could be over here, it could be over here, or over here. Our terminal side can be anywhere, right? So let's talk about what happens when our terminal side is in different quadrants. So remember that this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Okay, so just remember those numbers. So let's talk about what happens if our terminal side. So our terminal side is in quadrant 1. Okay, so if our terminal side is in quadrant 1, then what happens to our sine and cosine? So remember, our x and y are over here. Well, in quadrant 1, in the very first quadrant, we have a few quick little facts. We know that I'm just gonna move some stuff around here so I can fit it all into one little slide. So if our terminal side is in quadrant 1, I know that the point x, y, well, let's think about our point xy. Our point xy has the following properties: that x is going to be greater than 0 and y is going to be greater than 0. So they're both positive. Okay, they're both positive. If we have it in quadrant 2, so if the terminal side, is in quadrant 2. If our terminal side is in quadrant 2, well, let's see what happens. So again, here would be our point x, y. Maybe what I'll do is I'll do this. I'll call this the point x1, y1, because it's in the first quadrant. And we'll call this one x2, y2. There we go. That's a good way of explaining it. So x1 and y1 are greater than or equal to 0. In this case, x2, y2, when the terminal side is in quadrant 2, well, now x is negative, right? We're on the left-hand side of the y-axis. So here, x2 is less than 0, but y1 is still positive. Or y2 is still positive. Okay, so that's another fact. Going down here, so if I were to be in the third quadrant over here, then our point x3, y3, well, here's something kind of interesting. Now, it looks like, well, let's see here. Looks like I think that they're both negative, right? Yeah, they're both negative. So the terminal side is in quadrant 3. So when the terminal side is in quadrant 3, we get that x3 is less than 0 and y3 is less than 0. So both of our points, or both our coordinates, x and y, both of those are negative. Okay. So we've got one more fact here. So when we're in quadrant 4, so when the terminal side, you probably can't read this. When the terminal side is in quadrant 4, we get that x4, well, now x is actually back to positive. So x4 is positive, right, because it's on the right-hand side of the y-axis, and y4 remains negative. So basically, in these two quadrants, x is positive, right? In these two quadrants, x is negative. And in these two quadrants, y is positive, and in these two quadrants, y is negative, right? So that's the pattern that's happening here. So just a couple of things here before we move on. So note in these cases, the value of x and y correspond with cos of theta and sine of theta, where theta is the angle between the initial side and terminal side. Okay, so that's what we're talking about with sine and cosine, is that we're talking about the x and y coordinates of these points. That's what sine and cosine really actually correspond to, because you can really see it, right? Because like if I were to just sort of zoom in here, and I'll change colors so we don't mix everything up. So right here I have a right angle triangle, right? So there's my angle, here's my right angle. The y coordinate of this point is the opposite side, right? If this is our angle right here, like if this is our angle right here, then my y is the opposite side, and my x value, like the left and right value, is the adjacent side. And we said that the radius is equal to 1. That's the only thing that's not changing here, is the radius. The radius is always going to be 1 here. So so we have to keep that in mind, that the x and y coordinates here are actually equal to sine and cosine of theta, where theta is the angle between the terminal side and the initial side. So that's what theta is. So theta can be any angle that goes all around here. In fact, we could even have angles greater than 360 degrees, right? So yeah, just a couple things to keep in mind. There's one more fact. So here's a nice little fact for you. And this is a fact that I need everybody to memorize. It's not too bad of a fact. So sine of theta is equal to opposite over hypotenuse, right? Cos of theta is equal to adjacent over hypotenuse. And we haven't really been talking a lot about tan, right? Tan of theta is equal to opposite over adjacent, right? So let's see what happens if we take sine theta and divide it by cos theta. Okay? Now I'm going to give you 30 seconds to see if you can simplify this and get something familiar. So I'm gonna ask you to simplify sine theta over cos theta and see if you can come up with anything that seems sort of reasonable. Okay? So 30 seconds, go. Okay, looks like we're done here. So yeah, let's take a look at what we can do. So sine theta over cos theta. Well, I know that sine theta is opposite over hypotenuse, and cos theta is adjacent over hypotenuse. Okay. Now both of these fractions have a hypotenuse as the denominator. Now if I multiply the numerator and the denominator by the hypotenuse, so if I did hypotenuse over hypotenuse, well, this would cancel with that, this would cancel with that, and I would be left with, let me get rid of this, I would be left with opposite over adjacent, which is equal to tan theta. So sine theta and cos theta are really just expressions or a part of tan theta. So tan theta is just sine theta and cos theta combined. So imagine that. So just to be clear, the fact that I want to point out, and I'll make it nice and big, tan theta is equal to sine theta divided by cos theta. That's a fact, okay? It's a fact. You got to memorize that one. Tan theta is just equal to sine theta over cos theta. Now keep in mind that the angles always have to be the same. So we're talking about the same angle in all of these, okay? So I want to talk just quickly about one more thing, and then we're going to call it a day, and I'll leave you with a little bit of homework. Okay, you know what? Maybe I won't do homework. We'll do homework tomorrow because there's still a little bit more from the section that I want to cover. So we'll hold off on the homework for now. Okay. So what we're going to talk about now is which quadrants have negative or positive trig ratios. Okay? Well, let's talk about this for a second. So what I'm going to do is I'm going to make a little diagram here. So I'm going to write sine theta, cos theta, tan theta. I'm going to have sine theta, cos theta, tan theta. Again, sine, cos theta, tan theta. And then sine theta, cos theta, and tan theta. Okay, so if our point is over here, right? If we have a terminal angle here, well, we've already determined that sine and cosine are both positive, right? We've got a positive x value and a positive y value. So that means that the sine of theta is positive, cosine of theta is positive, and tan theta are all positive. I know that tan theta is positive because, again, tan theta is equal to sine theta over cos theta. So we would have a positive divided by a positive, which of course is positive, okay? So over here, now we have, well, in this case, sine theta is negative. Cos theta is still positive. Remember, cos theta refers to the y value, so we're still in the positive y's. The sine theta is negative now, but that's okay. Tan theta is going to be negative as well, though, because tan theta is the quotient of them. So we're dividing one by the other, which if I take a negative divided by a positive, I get a negative back, right? Okay, so let's try this one. Okay, so with sine theta, if sine theta is over here, that's going to be negative. Cosine theta is now negative as well because we're on the bottom half of the quadrants, right? But tan theta, on the other hand, because I've got a negative divided by another negative, I get a positive. Okay, and finally, sine theta in this case is going to be negative. Cosine theta is going to be positive. Hold on a second, I messed up. Shoot, oops, over here I messed up. Sine theta is positive here and cosine theta is negative, right? Because sine theta refers to the up and down, and the cosine theta refers to left and right. So I'm sorry about that. I messed that up. I think the other ones are all fine though. Yeah. So now in this quadrant, in the fourth quadrant, sine theta is negative because we're in the lower half. Cosine theta is positive, which means that tan theta is negative here as well. Okay. So this gives us a nice little mnemonic device. So I'm going to share with you the mnemonic device. C-A-S-T. Cast. Okay? So, with C, it's cosine only is positive. Here, it's all are positive. Here it's sine only, and here it's tan only. I should say tangent. Okay, so that's a nice little mnemonic device that you can use to remember which values are positive and which values are negative all at the same time. Okay, so it's cast. Now the only confusing thing about it is that it doesn't start in the fourth quadrant, right? The way the mnemonic device starts is that you're actually starting at the fourth quadrant and you're kind of going around like that. But it still is a nice way to memorize which values are positive and which values are negative. We're gonna end just a few minutes early because the next topic is kind of a big one. So I want to leave it for tomorrow. So for the exit slip today, what I'd like you to do, I'd like you to just comment on this trigonometry. I just want to know. So how is trig going? So how are you feeling about trigonometry? Is it super confusing? Is it too abstract? Do you totally understand it? Is it like are you understanding it in a way that you didn't understand it before? I really want you to be honest because I actually want to know, like, is this going okay? Like, do I need to change things up? So this is your exit slip. Exit slip. Tell me, how is trig going? Just be honest. If it's a rough one, if you're like, I understood everything that we were doing all year up until this point, tell me. I really want to know that. I really want to know how this unit is going. This is a very important unit, and I just want to make sure that I'm not sort of missing anything or anything like that. So tell me how you're doing with trigonometry. If there's anything that I can do to help, maybe we can start doing a few more examples. I know that we've been doing pretty much theory. I think this is our third class in a row where it's just all theory, which can be a little overwhelming, and I can appreciate that. But let me know how it's going. Next class we'll do some examples. I promise we'll actually do some examples. But there's just a lot. There's just a lot to absorb first, and once we've got all like these definitions and new ways of thinking about it, then I'm hoping that we'll be able to approach it in a way that makes a little more sense in a concrete way, that we can actually do some examples that we can actually see what we're supposed to be doing. But right now it's all theory, right? And trigonometry is a very theoretical part of math, and that can be a lot of people struggle with trigonometry. So I really want to make sure that we're doing okay. So let me know how it's going with trig. You can tell me anything. If you really don't like it, tell me. If it's going okay, tell me. If you're finding it's too easy, tell me. Just no matter how you're feeling, I want to know how you're feeling about trig. So yeah, we're gonna wrap it up there. Stay tuned for the document that I will post online shortly. And if you have any questions, don't hesitate to reach out. Bye bye.